Welcome to our latest Pictures by PC live CAD/CAM software presentation. Today we're going to be looking at the 5-axis simultaneous cutting and trimming of composite and plastic components. To start with here, we're going to use the feature recognition to find the hole positions, measure the holes 5mm diameter, and load an appropriate machining operation for the drilling of these holes. And what you'll see here, it's automatically grouped all of the holes with the same size together, okay, and it's got the positions and orientations. So that's completed. Good. So let's look at the first 5-axis cutting operation. We're going to cut the 3 pockets at the top, and I'm just going to select 3 lead-in positions, load a 5-axis operation, select the geometry to machine, edit the operation. You can see we're machining, we've got a depth of 3mm allowance, offset of 0. We can adjust this allowance and depth locally, so we can vary it along the part contour. The surface selection is the most important part here, because I want to remain with the tool orientation perpendicular to this surface, so I select the surface. We run the toolpath. The main advantage of remaining perpendicular to the surface here, 5-axis, is that we can maintain tighter machining tolerances and improve the surface finish compared to 3-axis pre-positioned operations. Okay, so that's the first 5-axis simultaneous machining. We're going to repeat this around the outside. So I'm basically going to create an outside contour here. Use the feature recognition to select the outermost faces and convert their edges into a machining contour. Point marker to lead it onto. 5-axis operation, cutting operation. Select the geometry as we did before. Edit the operation. Again, we determine the tool orientation through the surface selection. So I've selected all of the outer surfaces, and we'll simulate that. And you'll see here we're staying to the left of the contour. We're tilting the tool upwards as we stay perpendicular to the surfaces. Everything's looking good. If we look down from the top here, we'll see we've got surfaces with quite a strong curvature. If we remain perpendicular to these, we're going to tilt quite dramatically. So I'm just going to turn on the collision control between the machine head, the holder, and the part, and see if we have a collision when we tilt. And you can see here we've actually got a collision, so we need to reduce how far it tilts at these positions, and we can do that with 5-axis direction vectors. Basically, at different positions I can determine what the tool orientation is going to be. So you can see here I can interactively tilt the direction vector, and this is going to be my tool orientation at this position, and it's going to interpolate between those vectors. I'm going to do exactly the same on the other side. So again, I'm going to use 3 vectors. I'm going to tilt the middle one, so that's my maximum tilt angle for the tool. I can tilt this vertically and horizontally at the same time. Makes no sense here, but I can show that. Let's tilt this vertically as well. What we've also got, we've got some additional vectors that I've hidden beforehand to determine how I interpolate around the corners. If we edit the operation, and we'll pick up on the direction vectors, so we'll pick up on the green ones first of all that we generated, okay, and then we'll pick up on the ones that we were turned off, and then let's simulate this. So we'll go to the toolpath calculation again. So you can see here we're left of the contour, perpendicular to surfaces. Let's have a look at the tool orientation now, so you can see it's interpolating between the vectors. It's only going far as our maximum tilt angle and coming back. We take the isometric view, have a look at it here. We tilted this one vertically as well, and this not just horizontally. So you can see the machine head is coming up, tilting the tool up and then going back down. Okay, just to show that here. And then on the corners here, I've just set 2 so we can quite nicely come around the corners, interpolate around the corners. Along the back side I've only got 2 direction vectors, so it's going to remain in one position along the entire edge of that part if we wanted to machine it that way, and we'll come round again around the back here. So that's the 5-axis cutting. Let's generate an NC program. So we'll choose a post processor. Let's choose a Heidenhain 5-axis. Okay, look at the NC program that's generated that. Okay, quite nicely. That's good. We can quite happily come in here and select an entirely different controller. So let's come in and pick up on a Siemens controller. And now we've got a totally different program, obviously, for the Siemens. And then what we can also do, we can generate a CNC PDF information sheet. So it's a PDF and it's going to show what the part looks like, where the zero position is, and what tooling and machining operations we've got. So 5-axis simultaneous trimming and cutting. Thank you very much for watching. If you've got any questions, let us know, and we look forward to seeing you soon. Thank you.